Okay, so in this video, we're going to be revising the quiz 3 for Math 1120, and we'll start with question 1. This is the Math 1120 quiz 3 for this academic year. This will help you to prepare for your test 2 and also see the mistakes that you made. So question 1a, they're saying find the exact value of sine 330. So 330 is simply in the fourth quadrant, and in the fourth quadrant sign is negative, so this has to carry a negative sign. Then we say 360 minus 330. This will become negative sine 30. According to your special angles, sine 30 is simply half 1/2. So this is what you get for the first part. And the second one was saying cos 7 pi over 6. The exact value of this, we have to convert it from radians to degrees. This is going to be 7 pi over 6 multiplying 180 over pi. The pi cancels. 6 there is 1, 6 there is 3. This gives us a 210. So this is the same as cos 210, which is in the third quadrant. And in the third quadrant, cos has to be negative. And in the third quadrant, we always do the angle given minus 180. So this will simply be cos 210 minus 180. This gives us a 30. This will give us negative √3/2. That's what we get. And question 1b says there is cos A, which is negative 3/5. Between the quadrant 180, so A is between this, meaning this is supposed to be the third quadrant, because 180 to 360 means the third and the fourth, and between the third and the fourth, the only place where cos can be negative is the third. So the triangle for A is going to be in the third quadrant. So cos A, which is adjacent, hypotenuse, then we can get the other guy here. This should be a 4, and we can get the other 2, which is sine A. Sine A, this also has to carry negative. This is 4/5. Then tan A is simply opposite over adjacent. So this is the main reason why tan is positive in the in the third quadrant. This is what you have. Then there's also B. They're saying sine B is equal to half, where it's in the first quadrant, right? So this is in the first quadrant. Yeah, so if sine B is equal to this, meaning what is this value there? That's going to be 4 minus 1, that's going to be the √3. Yeah, so we can get the 2 as well. We can get cos B, which is √3/2. We can also get tan B. Yeah, tan B will just be opposite over adjacent. Yeah, so now the first question they're asking for is, the only question they're asking is for us to get sine A minus B. That's what they want. This is equal to sine A, then cos B, minus, this is sine B, then cos A. So sine A is simply going to be equal to, according to what we got here, sine A is negative 4/5, and cos B is here, which is √3/2. They are in the first quadrant, so all the ratios are positive. Then sine B is half, then cos A is negative 3/5. This will give us negative 4√3/10 plus, that's going to be 3/10. This will be negative 4 plus √3 plus 3, negative 4 √3, then plus a 3, everything over 10. This is what you get, which can be written as 3, something like this. This is better. So that's the exact value of sine A minus B. Then the last question on 1, so C1, this is going to be, they're saying show that cos, they're saying show that cos x plus 90 is the same as negative sine x. That's what they want us to show. So we'll start with the left hand side, which is cos x plus 90. This is the same as cos x, cos 90, then minus sine x and sine 90. So according to your graph, you know that cos 90 is supposed to give us a 0, right? According to the cosine graph. The cosine graph looks like this. 90 is here, so it's 0. So that's going to be 0 times cos x. Everything becomes 0 here. Then minus sine. Sine 90 is simply a 1. So this will just be 0 minus sine x. This ends up to be negative sine x as required. So we've shown it. Yeah, this is your C1, question 1C. Then the last question there, or number 1, they are saying solve for x in the equation. This is sine, this is C2, sine 4x plus sine squared x, then minus cos squared x, then this is equal to a 0. We know what this is supposed to be. This is the same as cos 2x, right? That's what we know. There's a double angle that says with a negative, we can just reverse it. Remember, cos 2x is equal to negative, it's cos squared x minus sine squared x, right? So this is like us reversing it, or rather, let me show you here. Let me show you why we're putting a negative. So we're going to have sine 2x plus 2x is equal to, here I'm going to reverse this and write it as, I'm going to take it on the other side so that you can see it clearly. This is going to be, the cosine goes this side, becomes cos squared minus the sine this side, right? Then this, you're able to see, it just becomes the usual cos 2x. Hope it's now easy to see. Then here, this is sine. So we're going to break it down to be sine 2x and cos 2x, then plus again sine 2x and cos 2x. Because the angle is the same, is 2x, 2x. These guys are the same. It's like 2 sine 2x and cos 2x. So hope you are seeing this. Is equal to, I bring this, instead of saying is equal to, we bring it on the other side. Here what's common is cos 2x, right? I factorize it. What remains is 2 sine 2x minus 1. This is equal to 0, meaning cos 2x is equal to 0. So cos inverse of 0, this is 2x, cos inverse of 0, there are two angles that can give us a 0 for cos. There is 90 and there is 270. So we're going to get x is equal to 45. When you divide this guy by 2, divide this by 2, it will give you 135. So we have these two angles. Then we solve this part as well. That's 2 sine 2x minus 1 is equal to 0. 2 sine 2x is equal to 1. Divide both sides by 2. This becomes sine 2x is equal to half. So meaning 2x is equal to sine inverse of half. What angle from the special angles gives us half for sine? That's simply going to be a 30, right? So we have a 30. The other place where sine is positive is the second quadrant. So 180 minus 30, that gives us 150. So we can divide everything now by 2. X can also be a 15 degrees or a 75 degrees. Yeah, they wanted the answers that are between 0 to 180. That's where x must lie. That's the answer. So we check, everything here falls in that category. So these are all the solutions. Yeah, so you write properly. You say your answer, x should either be, there's a 15 degrees, then we've got a 45, then there's a 75, then there's a 135. They all belong in the interval 0 to 180. This is your answer here. So that marks the end of question 1. That's what you have. Now, probably you're wondering, why are we able to do this fast? It's because we are familiar with the rules. I know how to use the rules. You see that it's only been 10 minutes and we're able to solve one full question without leaving anything. We're showing all the working. So with more practice, that's how you get to improve on your speed and your accuracy. And this is trig, so you have to master the rules. It will make it easier for you to know what to do and what to manipulate. So let's go to question 2. Question 2, they're saying use compound angle identities to find the exact value of the first one. So 2a, number 1, so this is cos 22, and then you have cos 8 minus, this is sine 22, and then you have sine 8. So are you okay if we say this was the same as 22 plus 8? We're just trying to backtrack. Remember, if you have cos A plus B, this is what becomes cos A, cos B, then minus, then sine A, sine B, right? That's basically what I've done. The A is 22, the 8 is simply what? Is a B. So this is what you have. We're just going backwards. So this is the same as cos 30, meaning cos 30 is the same as what? Root 3 over 2. So that's what you have. Hope that's okay. We're just backtracking. The next one, number 2a2, they're saying tan 75. Tan 75 is the same as 45 plus 30. This is just going to be the double angle for tan, right? The rule says if you have tan A plus B, this becomes the same as tan B. Tan A plus tan B, rather. Tan A and tan B. Then you have a 1 minus your tan A and your tan B. So we're just replacing. This is a 45 and a 30. Tan 45, then plus tan 30 over 1 minus the same, just multiplying them. You have tan 30. This is going to be the same as a 1. Tan 45 is 1. Then tan 30, this is opposite over adjacent, should be 1 over root 3. So we're having 1 minus 1 over root 3. The guy on top is going to be root 3 plus 1 over root 3. This is being divided by root 3 minus 1 over root 3. This now becomes root 3 plus 1 over root 3 times root 3 minus 1. This cancels. We have a root 3 plus 1 and a root 3 minus 1. We rationalize this to get rid of the conjugate down. So this is going to be multiplied by root 3 plus 1. So the guy on top is just going to be a 3 plus a root 3, then plus a root 3 plus a 1. At the bottom, you just have a 3 minus 1. So this would just be a 4 plus a 2 root 3. Down you have a 2, divide everything. It just becomes this. This is tan 75. So that's what you get for part A, question 2A. Then part B, they are saying prove the following identity. So we're having sine 2x and sine x is equal to, there's a cos x, there's minus cos x, then there is another cos 2x, right? So I'd rather get things that are a little bit separate. We'll start with the right hand side. So we have cos x minus cos x and cos 2x. So we can say cos x minus cos x. This here becomes, we can say this is the same as what? This is the same as cos. Okay, we can just flip it to be something that looks familiar. We can change it to be 1 minus 2 sine squared. We can have this. Then this becomes the same as cos x. So here I multiplied the cos and the 1. This is what I'm getting. The cos and this becomes positive, right? Yeah, so I just changed this according to that rule that says cos 2x is the same as 1 minus 2 sine squared. That identity, that's the one that I've used here. Then from here, you are seeing that the cos and the cos are cancelling, they're subtracting. So we'll just remain with 2 sine squared x and also a cos. Then this, I can just rewrite this, split it to be the same as, there's a sine x, there are two of them, right? Then there's a 2, the one that remains, and there's a cos. You are seeing that this here is the double angle for sine, so this is where the sine 2x came from. So hence we've shown this happens to be our left hand side. Yeah, so that's how we show that the right is equal to, so this is equivalent to the left hand side. Then we've proven. So that's what you have on question, the second one. Yeah, the question 2b, that's what you have, that's identity. Then the last question is C, 2c, 2c1. They're saying f of x is equal to 1 plus, this is 2 sine, there's a 6x. So before you even look at your question, follow the rules on what you're supposed to get. The period is simply going to be 360 divided by the b is 6. So this is going to give us a 60 degrees. Phase shift is 0 here. Yeah, phase shift is 0, so you say x is equal to 0. Then the amplitude is going to be modulus of 2, which is just a 2. And we have a vertical shift which is just 1 unit upward. So that's what you have. This gives you a total 4 marks, you just by stating this. That's what you have. Then they want you to sketch this now. When you're done, you're supposed to sketch. So if we are to sketch this, they want the whole diagram, the sketch, to be shown only between 0 to 120. We know there should be 6 waves, right? 60, 1 a wave, here again a wave, and so on and so forth. They just want you to show it up to 120. This is what you have, another wave there. So the first thing we have to apply here is our amplitude. That's a 2, that's a 2. There's a 0 there, right? This is a negative. Then the vertical shift, this thing moves up by 1 step. So if it moves up by 1 step, I'll show it in red. So 2 becomes 3, 0 becomes 1, so 1 now becomes our new line of access. Then negative 2 becomes negative 1. Everything that was at negative 2 comes at negative 1, because we're adding with a 1, right? Moving 1 step up. So now this is going to be something that looks like this. We have something here, then something that comes there. So this is basically what you're going to get. Yeah, you can state by the side, state the range. The range is simply now from negative 1 to 3, and the domain was already given. The domain was already given to be a 0 to 120. That's why we're ending on. So this is the whole quiz 3. Thank you so much for watching.